This is a 6-inch rotary table that you can get off of eBay. I purchased it on eBay. That wasn't too much money. I think it was made in India. Came with a crank handle and has a 90-to-1 ratio between the number of turns on the handle and the table. And it seems to be a fairly solid kind of thing. It's got a worm gear in it. And so what I did was to 3D print a shaft coupler, which is that black plastic connector between that and a NEMA 23 stepper motor. And so it can be driven by this stepper motor driver, which is capable of driving it in micro steps, which means that for every pulse from my controller, it gives me, for every 5 pulses, it gives me 1 step on the motor, and the motor's got 200 steps per revolution and 90 steps in the worm gear, and so that turns out to be 90,000 pulses for full revolution of the table, which matches what came on my machine tool. So I'm hoping that'll make it interface. And so the controller, you can set it for current and whatnot, and to get it to run well, I had to set it some fairly high current. So if you look at the power supply, it's drawing about 22 watts even at rest, so it seems to draw power no matter what. And at the, I don't know if you can read that, but the frequency of my signal generator set to 1 kilohertz, so let's turn that on. And with that turned on, it's 1 kilohertz, so I guess that means it would take 90 seconds for a full rotation of the table. And I've got a little shaft coupler. I put a little window in the coupler there, and in fact you can see the motor moves just a tad, so the shafts aren't perfectly aligned. I might have to do better, but I basically 3D printed a little connector between the 2 different shaft profiles, and you can actually see it turning through that little hole I put in there. But it looks like it's going to work. And if I go back to my signal generator, if I kick it up to 2, 3, 4, 5 kilohertz, that would be like, I think, 18 seconds per revolution. I think at some point the motor will stall if I keep going up. See, at 15 kilohertz I got nothing. Let me just bring that back down until... Okay, so at 6 it'll turn at that current. Now I can set the current on this thing to various levels, and I'm not sure if the machine tool can put out 25 watts on the 12 volt line, but that actually, really pretty pleased with that. It's kind of fantastic, really. And so if I can get the interfacing done, and maybe I'll have to come up with some kind of a flexible shaft coupler, because there's just a little wobble in that motor. I thought there might be enough play in the 3D printed just straight coupler to compensate for the shaft alignment, but not perfect. Anyway, I'm actually very pleased about it.